Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at making math stick. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI Technology to make those tough to teach, tough to learn concepts accessible to all my students. I'm really excited to be joined by our two panelists tonight, Karen Camp and John Lemaster. Karen was instructor of mathematics education at Yale University for 15 years and taught high school and middle school mathematics for 13 years. She's been a T-Cube national instructor since 1998 and has been an author of materials for summer workshops and TI instructional websites. Karen speaks often on how to use technology effectively to enhance student understanding. Karen, thanks so much for joining us.
Mike, I'm really excited to be here.
And John has been a part of the T-Cube family since 1993. He presents annually at conferences, writes math activities, and provides feedback to Texas Instruments on software and products. He teaches mathematics at Indiana University, Purdue University, Fort Wayne. His passion is to empower students with technology to mathematize their world. John, thanks so much for joining us.
It's great to be here. Thanks, Mike.
We're expecting a large crowd, so your audio is muted. Feel free at any time to send questions to Karen or John using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, this session is being recorded. You'll receive a link to the event certificate of attendance as well as the documents that are being used tonight at the conclusion of the event. We hope you don't have any audio issues tonight, but in the event that you do, you could try one of two different things. First, try selecting Communicate at the top of the WebEx menu and choose Audio Broadcast. If that doesn't work, find your name in the participant window. In that same window, in the lower left or lower right, there's probably a little icon that looks like a phone. If you click that phone icon, it will give you information to call in using a landline or, say, a cell phone. At this point, Karen is going to discuss our agenda.
Thanks, Mike. We've already done our welcome and introductions. So the rest of our agenda is, first of all, to find out what is the action consequence reflection process. We're going to use graphing styles and tables. We're going to graph linear, quadratic, exponential, and piecewise functions. We'll use the transformation graphing and Cabri Junior apps. And we'll discuss some questioning techniques to make math stick. At the end of the webinar, we'll discuss some online resources, and somebody will win registration for two to the 2018 T-Cubes International Conference.
Thanks, Karen. And John's going to discuss our expected outcomes.
Thanks, Mike. Tonight, our expected outcomes focus on ways to facilitate deep learning, which will involve students performing mathematical actions with technology, followed by targeted questions to help them be cognitively active. We'll explore in these content areas listed here classroom-ready dynamic activities that take advantage of multiple representations, and share how these activities can engage your students in discussions that promote higher-level thinking. Interspersed throughout tonight, we'll show some features of the newest TI-Nspire operating system and the Smart View, which was just released, but our activities can be used for the entire TI-84 Plus family.
John, thanks so much. Karen, it's all yours.
Excellent. Can you see my screen? Action consequence reflection process. Okay, so what is this all about? Students are going to be performing a mathematical action. It might be on a graph, a geometric figure, a symbolic expression, or a list of numbers. They will then observe a mathematical consequence, and we want them to ask and answer the questions. What did you observe? What changes? What stays the same? Then we want the students to reflect on the result and reason about underlying mathematical concepts. This reflection piece of the process is really, really important for students to be able to make sense of the math and make their learning deeper and more measurable. This reflection step, you can't just leave it to chance that the students are going to reflect on what they've observed, and if they reflect, they may not be reflecting on what you think they should be reflecting on. So there's lots of strategies that you can use to get this reflection piece. You can have them record their results in a lab activity or a handout or in their notebook or in a class summary at the board or on a chart paper. You can have them answering questions, discussing implications in small groups, making predictions, and in general, you just want them to be able to communicate their thinking orally or in writing in small groups or in large groups. And so let's take a look at this action consequence reflection process in an activity and how we can get students to go through these steps. What we're going to do is we're going to take a look at transformation of quadrilaterals. So we're going to begin with a stretching the quads activity. This is in your associated documents folder. And before we even get involved in the transformation graphing app, let's take a look at how you might graph quadratics on your calculator. I'm using the TI-CE emulator. Keep in mind that what the TI-CE emulator gives you is it gives you 3 different emulators, the CE, the C, and the TI-84 Plus. And even if your students don't have the CE, you can have the emulator in the CE mode that gives you color and some of the new features of the newest operating system that we're going to share with you tonight. So let's begin with a very basic quadratic parent function, y equals x squared. I'm going to graph that on a standard window, and here it is. Standard window is the window we know and love, x min -10, x max +10. And when I take a look at this graph, I want to display something that's going to help the students make this math learning stick. So one of the features that we have on the color versions of the calculator is in the format window right above the zoom button. So second format, I can change the grid to have lines. In the black and white calculator, you can do dots, not lines, and you can have the grid on or off. So those grid lines automatically give me a whole lot more information about the graph. And it appears that I don't have the same distance between my tick marks on the x-axis and on the y-axis. This isn't a square aspect ratio. So what I like to use one of the 2 square windows. I can either go to zoom square, which will square off the window that I'm using, or my favorite is zoom decimal, number 4. And the zoom decimal zooms me in, and you can immediately see that we've got square grid lines. And so now we realize we have equal aspect ratios. So that's just a little bit that you can use, and it's a way of displaying something that will help make the math more meaningful for the kids right off the bat. I see a question in the chat. The grid lines don't work on the non-color calculators, but you can do dots. So you can see sort of a field of dots. Okay, so this is y equals x squared. What we want to do now is to talk about how we can make this dynamic. Even if you have never done transformation graphing, you may have done activities where you have students graph different quadratics and observe what happens when you change different parameters. And so we're going to look at this activity of stretching the quads. And stretching the quads is basically going to talk about how can we stretch the quadratic y equals x squared, and then we're going to look at other versions of this quadratic formula. So we're going to use the app Transformation Graphing. It's really easy to use. We need to clear out any equations that we had or any plots. Go to the Apps button. Transformation Graphing is generally near the bottom of the list, so I'm going to arrow up. and I'm going to turn on transformation graphing, and it looks like I'm back in my regular calculator screen. And we only notice something has changed when we go into y equals. Now, if you have the newest operating system downloaded, you will see 2 of these play pause indicators. And if you do not have the newest one downloaded, you will see all of the y equals will have the play pause indicator. That's what the prior color version looked like, and the black and white version will also show all of those play pause indicators. Okay, what we want to do is we want to put in the parent function x squared, but we want to include a parameter a. I don't need the multiplication symbol. The implied multiplication is understood, but I like to put it in for clarity, and also because on the TI-Nspire device, an AX actually acts as a different variable, so that's why I do it. And then let's see what happens when we graph this. Okay, so now I'm on my screen, and what is new on this screen is a equals 1, and it tells me what my parameter is. And this is dynamic because I can change that parameter and watch the screen change as I'm going. I use my right arrow to increase my parameter and my left arrow to decrease. And think about what questions you would ask your students as they're watching this change. What do you want your students to observe or reflect on? And here we're going down. Down is a left arrow, to 2, to 1, to 0. That's an interesting graph. Is it a quadratic graph? -1, wow, that's different. -2, etc. And the handout that the students can have asks some questions here. It asks, what effect does the variable a have on the graph of the equation? What happens when the coefficient is negative? Then what I really like is it changes some things around here. Now it's giving students graphical representations and asking them, what was the coefficient? Is it positive or negative? And really, the most important thing that I like about this handout is the idea that it's telling students to experiment. It's not telling them to do certain values. It doesn't say to go to a certain point. It gives them the opportunity to elaborate and experiment and see what kinds of results they're going to get. Okay, so let's take a look at what else we can do with this. We can go to the setup. If you're on the newest operating system, you will see this setup hotkey that would press the graph button to bring us to Windows settings. And if you haven't updated your operating system yet, don't worry. We can get to this by pressing Window and arrowing up to Settings. And one of the things that you'll see here is we can change the step size. So our step size is going to be 0.1. I want to start my A back at 1. And when I look at the graph now, I can, again, increase, but now I'm increasing by a smaller increment. And I can decrease, and I don't have to jump from A equals 1 to A equals 0. And I can see what happens, and I can get a wider parabola. Let's see what else is in that setup mode, or setup screen, excuse me. I can, there's 3 different play modes. The one that we're in right now is play pause. The other 2, this play and this fast play, will create a mini slideshow. So let's try that out. If I go to play, it asks me where do I want A to start, and what do I want its step to be, and where do I want it to end. So let's start at -5 and step through by 1s to 5. So when I go ahead and hit graph, it's going to compute my screens, and now I can sit back and watch a slideshow. When you're done with the slideshow, hit enter, to break out of that graphing, and we'll go back to our settings and go back to play pause. The last setting I want to show you, again, it's in the newest operating system and it's an enhanced feature for the CE, is that we can now turn on a trail. So watch this one. If I set my A back to 1 and my step to 1, and I graph, now I'm going to increase A, but I am going to leave a trail behind. And this is really pretty amazing to watch and to see the trails of what has changed. Okay, we're going to get to a little bit more complicated why parent function, rather than just have an A value. I want to put an extra function, the parent function, in Y3. Again, an enhanced feature of the new operating system is we can have 2 different transformable graphs, plus other functions can graph at the same time. We still are limited to 4 parameters, A, B, C, and D. But let's now go up here, and what I want to do is I want to do one of the more robust parent functions for quadratics. And I want to maybe do vertex form. And I can type that all in, but what's an enhanced feature of the newest operating system is if I arrow to the left here to the graphing styles, I can access stored functions. There's linear functions. Here's one version of a quadratic. Here's the vertex form I'm going to use. And as I'm just clicking through these, you can see I've got other quadratic forms, cubics, absolute values, sine, cosine, and tangent. So we're going to take a look at vertex form. But there's all those to choose from. And I want to go to my window just to see where my settings have started. Now you'll see in the window settings, I'm going to turn off my trail. You can see in the window settings that I now have parameters for A, B, and C. So let's start my A at 1. Let's see what the graph looks like. The black graph is my parent function x squared, and the blue graph is my transformable graph. Right arrows are going to increase the highlighted parameter. So here I am stretching my A, stretching my quadratic graph, and an up or down arrow will move me to another parameter. And on the handout for the kids, because again, the questions are the key things here. The handout asks the kids to experiment with A, B, and C. It asks what do B and C represent. And it gives students questions based on other representations. Look at the graph. What's the vertex? Giving them algebra expressions. Would you make a graph? And it's asking students to go back and forth between these representations. All of these techniques are going to help make the math more meaningful. Let me show you one more thing here. You can, if you want, put in a formula for kids to match. Now, let's say you're working on your smartboard and you can freeze your smartboard or put a something to block your projector. And let's say we wanted to put in, first of all, I can turn off an equation, but I'm going to put into Y4 just another equation. And I wouldn't want students to see this. And now I have my new pink graph, and this is when I would show the equation to students. And the idea here is, can we change our parameters to match the graph? And so this can be another activity where you are asking kids to use the dynamic setting to make their math more meaningful. Right now I'm working on B, which is the x value of the vertex. I'm going to arrow down to C. I want to increase C, the y value of the vertex. Then I want to change my A. Looks like A has to be negative, so I left arrow. And it looks like I'm not quite stretched enough, and there I have it. Okay, that is what I wanted to show you about transformation graphing. When you're done with transformation graphing, on the y== screen, you can arrow up and over to Quit App. This works on any of the color calculators, and in the black and white calculator, you have to go back to Apps and Transform again. And
Karen, before you hit that button,
oh, yes.
Can you, there was a question from Padua about changing the step size for A.
Oh, yes. Okay. So let's go back. If I hit Window, I need to arrow up to Settings. And I think that once you change a step size, it becomes the step size for all the parameters in the problem. So if I wanted to change my A step size to 0.1, I think that that's going to also change the step sizes for B and C as well. I'm not sure if that was the question. I do see that Jenny asked about the trail setting will not stop. What it seems to be is if you go back to Window, Settings, you have to actually either turn the trail off. If it was on, you have to turn it off. Because I was having, if you have the trail on, it's not like it's going to erase itself just on the way. You have to turn it back off. Okay, and as for an animation, if the animation of that slideshow doesn't stop, what you have to do is you have to press Enter to pause and then go back to the settings and switch your mode back to the play pause mode.
And one other interesting thing about this, if you press your graph button, is there a way, suppose I really was in a weird mood and I wanted A to be pi, how could that happen?
So once you have an active parameter, you can just enter a number. So if I wanted to change it to 2, I could just enter 2, and there my A is 2.
Awesome.
And if John's in the mood he's in and he wants to put pi in for A, while A is highlighted, just enter pi. So that's second pi, and there it goes.
So I could even control my step size of A manually with everything else. Yeah.
Yes, absolutely. If you know what you're aiming for, you can type in any value.
Thanks.
Okay, so we have so much to show you. There's tons more that we can do with transformation graphing, and I do encourage you to look at the entire Stretching the Quads activity because there's so much in it. But we're going to quit out of transformation graphing. And one of the things that I want to go back to before I go to my next activity is I want to go back to a PowerPoint again. And the reason I want to hit this, I'm trying very hard not to show you lots of slides, but what's important here for you as the teacher is to ask good questions. Ask the students, what will happen if I do this? What must I change to make something happen? So what must I do to make my parabola go upside down? Or what must I do to get the vertex to be in the second quadrant? How is one thing affected by another thing? What changes, what stays the same? When will something be true? Why do you think this happens? And these questions can be out loud in large classroom discussions, especially if you are displaying on your TI Smart View emulator. But the questions can also be things that students are discussing in groups or on, in their notes or on activity sheets. The last two items here, question shells, are question frames or mazes that you can have students work through to generate their own questions or pick from multiple options. And the last idea is to reverse your directions or reverse your order of representations so that you give students practice with moving from an equation to a graph or a graph to a table to an equation so that they have that practice. Okay, so the next two activities I'm going to try and show you very quickly because John has really great stuff to get to. But I want to show you a Cabri Jr. activity and an absolute value activity. So what I'm going to do for the Cabri Jr. activity is I'm actually going to go to the TI-Nspire part of my emulator. And the reason I'm doing that is because I don't need, there's nothing special that is updated in Cabri Junior for the CE version. And it's going to give me an opportunity to work over here. So I go to Apps. I'm going to go to Cabri Junior. And the activity that I'm going to work with is going to be the classic interior, exterior angles of a triangle. And if you're a geometry teacher, there's lots that you can do with this, and you can certainly just tell the students what the rules are about interior and exterior angles of a triangle. But it's so much more powerful if you give them the opportunity to explore it themselves. If you've never used Cabri Junior, it's really easy to use. Let me just give you an incredibly brief, where did it go? Here it is. Incredibly brief introduction. The tool menus are accessed by the graphing keys. You grab objects using a grabber hand with the alpha key, and clear lets go of things you've grabbed and exits tools. Okay, so here is Cabri Junior, and what I want to do is I want to open a file, and depending on your needs, you can have a previously created file, this ready-made file, or you can give students a partial file where the measurements are for them to find out, or you can even have students create their own. But for a very fast action consequence reflection process, let's use this ready-made file. Now there's a lot of stuff going on this file. There is a triangle with 3 angles measured, interior angles. There's an exterior angle measured, and then there are 3 different sums that are calculated on here. The sum of the remote interior angles, the sum of the exterior and the adjacent angle, and the sum of the 3 interior angles. And I'm hoping that you notice that my cursor is a solid arrow, and as I get close to a point, it's going to change. Did you notice that? It changed to a hollow arrow, and the point behind it is blinking. That means that that object is available to be grabbed. So I'm going to grab using my alpha button, and I'm going to move point B. And let's watch what happens. What do you notice? What changes? What stays the same? And keep in mind that the sums that are on the screen are also being recalculated. They don't happen to change. We know that. We're the math teachers. The students might not know that. And I would have the students examine this, see if they can make different kinds of triangles. What happens if I make an obtuse triangle? What happens if I try to make a right triangle? What changes? What stays the same? When you have a sum or a quantity that doesn't change, it's known as an invariant. And invariants turn out to be really important in geometry. And what I would have kids do is I would have them put some information into a chart here, record some measurements, make some observations about the exterior angle and its relationship to the other angles. I want students to think about different triangle types, and I want students to make some conjectures of what do they think is true. So the activity that you will see in your documents folder has a much more thorough coverage of this. But you'll notice at the end it has students applying the math to other figures. You can also ask them to generate their own figure. And something that's really, really important is to summarize the mathematical findings for everybody before you go ahead and test on this. You want everybody to be quite literally on the same page. You want whatever math you thought was important to be talked about as if it's important. So students can summarize other students' thoughts. You can summarize as the teacher, or you can have a class list of what they discovered. Okay, so that was just a little taste of Cabri Jr. I'm going to go back to my TI-84 plus CE part of my emulator, and I'm going to give you, again, just a little taste of absolute value and piecewise functions. So absolute value is one of those topics that can be really confusing for students. What we're going to do is we're going to talk about how absolute value can be represented as a piecewise function. And the algebraic manipulations involved in this can be tough for students, and it can also be confusing about why this works. So what I'm going to do is let's take a look at y equals. Now, even though I was out of transformation graphing, I still have these equations still in here. And by the way, if you graphed now, well, before I had deleted the ones with the A and the B and the C, those parameters still have value. So those parameters would still have graphed. Okay, so very quickly, I want to graph absolute value of x. I use the alpha button and the window to get my shortcut for my absolute value template. It's also found in the Math Num menu. So here's absolute value of x. Then what I want to do is I want to do the piecewise function. And I'm going to show you the enhanced piecewise graphing that's with the new operating system for the TI-84 plus CE. Don't worry if you don't have a CE or you don't have the new operating system. The instructions in your document will show you how to do piecewise functions on the older operating systems. But we're going to go to Math. We're going to arrow up from the bottom to the bottom for piecewise, choice B. And we're going to use two pieces, and we get a piecewise template. So let's put in x for the positive half. And over here, I want to put in x greater than or equal to 0, so I type x. And the test menu right above the math, use second math. I'm going to use the inequality operators that are here, so x greater than or equal to 0. And then I want the opposite of x for the other side. And some of you may have noticed that the test menu now has conditions over here. Let's see what that is. Conditions now have quick templates here. So I don't have to type the x and then get the inequality. I can just use x is less than. And so this is going to be my piecewise. And what I want to do is I want to show you the graphing style on the left. And this works for black and white calculators, the entire TI-84 family. I want to change my line style to a tracer ball. This is one of several styles. And the reason why I want to do this is because I want students to see how the first function is graphed, and I want the second function to trace over it to confirm that they are actually equivalent. And you can see that tracer ball going. And in the handout, we ask kids to think about how you can confirm this. What other way can you check that your functions are the same? Because students might be thinking of numerical ways. And I really want to pass this over to John, but let me just scan through here. I take the students through piecewise formulas that are only slightly different. I prompt them to ask, how do they think they can find the boundary x value? What algebraically do you have to do to get the absolute value expression? And the whole idea of doing it graphically is it might help students make more sense of an algebraic technique where they were used to negating the stuff inside, and it might connect to other math knowledge that they have about transformations of graphs. And then I switch to other representations and ask students to go from a graph to the two different function notations, and what do they prefer? And as you can see, there's alternate instructions at the bottom. But let me give this to John. Thank you so much.
Thank you, Karen. This was, as we passed it, Pat, we had another good question about how much time do these activities take, and can they be done in a 45 to 50 minute period?
Well, I think that every teacher knows your students best, and you'll find in our documents that we give you Word documents so you can edit them and adapt them for your own students. Try them yourself first, and a lot of times I've broken these activities up into more than one class period depending on how many parts I wanted to explore, or I did some of them as a demonstration rather than a student individual exploration because I can get it done a little bit more efficiently.
I think I agree that it is one of those things where you can stop and start many different places with these activities, and one of the things that's neat about our Smart View that I'd like to share with you is a way to help facilitate that. And one of the content areas that's very big that we have need to develop is the understanding of linear and exponential. So this document that you're seeing on your screen will be in your packet that will give you directions later how to get to it. You can see I have an activity here that has y1 and y2 populated with 2x and 2 to the x. And what I'd like to do is share with you that's already loaded in my calculator. And what's really nice to compare these is a feature that also is built in on all of the calculators that you have, from the 84, I think even the 83. So if I press second window or second table set, I'd like to now change my dependent to ask and see what really now gives me some new power by doing this. So with the ask being on dependent, I'm sort of free to ask for my output. And so I'm going to go to the second table to see that I have no table showing. Oh, the handout.
John, if you had done auto, that table would have filled in like most of us are used to seeing.
Yes, thanks. And that auto then it means everything is, yes, showing automatically. Let's notice that over here I've got what they call the view cubed, where I can actually get the graph. And the handout does show how you can ask these questions about multiple representations. So with the graph as well as the table that I haven't populated yet, which is kind of rigged, what do you notice? And sometimes students may notice they look kind of like there's an intersection point. We're going to go right there with that. And what I'd like to do is I can control, because I get to ask for the output, I can control anywhere I display or unveil it. I like to call this Vanna White mode, where she's turning the letters, and students can even, help me turn it. Now, it looks like these two are not really much different from each other if I happen to be picking these. And sometimes it feels like Easter egg hunting. And as I unveil these, I might now start noticing how do they grow differently, and ask that question, just the way you, Karen, had asked what's different, what's the same. And it's very nice in that these have a lot that are kind of the same, but they grow much differently. And one nice thing about the dependent dependent ask is that I can then start predicting what might be down here. So there's a very nice little action consequence there, and I can, what I'd like to do next is load a different part of the activity, which we can get now a populated table. And so I'm going to move that off so we can see it. And one of the things that's nice about the newer Smart View is that you have load emulator states. So it's like I have an entire different calculator. I'm going to load a state that has that question already set up. And I'll hit load. And this now is as if I had a class period where I had to stop, and now I can save that class and load it and name it. And I'll show you how to save a state as well. So we'll get the state saved and state loaded. And here's a different activity. Now, I have not given any equations to my students here, And I'm going to ask them, this is sort of like Name That Tune. If you've older and you know that show, can you tell me what's the next one? Well, maybe not unless you unveil a few tiles, and then they can even guess which one's the exponential and which one's the linear. So now you've got, even though they're not running it, they're driving it. They're telling me where I should go, and now could they tell me what might be next? And you can even type it right in the chat, what you might think it is here, and then I can unveil it and see that maybe I want to notice what 2e6 means, and that there's a factor of 10 coming out here. But I've really designed this now so that it does not require them to get the formula here. You've nailed it, Myra. Nice job. And in fact, they might even be able to tell me this one without the previous if they've got their formula, and similarly here. So then what we'd like to do is maybe I want to clean this up a little bit and save this, wipe it all out and get it ready for the next class, or save it. If I went to y equal and clear this, this is one way to get the entire table clean again. And then I'll put I might ask them what would be the equations in here. And it was 2x plus 10. And so then they have, I can get this saved. And I like to have the 2 plus 10x, even better. I like to have this put in there so that it's all set, and then I can pick what I wanted unveiled, so I can get this ready just for them for the next class, and I've got it clean. And then what I'll do is actions and then save. And then I just make a name for it and call it period 1. So I can reset the activity and not have to do any of this. And you notice what happens is that the activity can be brought in without me even hiding the display. So there's a question that you mentioned, the maze, and what's nice about the maze question is if I have written up how a linear and exponential compare, you can do this maze where they have, if you notice what's not in the braces, the curly braces, everything else outside of the curly braces is nearly identical. And so the structure of the question itself helps them compare what's the same, and they have to then kind of circle the choice in the maze to be able to, which is easy to grade, which is able to say, now here's how they're different. And so we would notice that outputs, we're looking at the difference in the outputs, and the outputs then are consecutive, or have a constant difference. The ratios have a constant, the outputs have a constant ratio for the exponential. Now, you had asked a question about saving on the emulator. That's just a state on the emulator. So this is just for the teacher display, that the emulator would then be saved for you to display. And honestly, I have a mixed calculator classroom that has many different versions in it, and I will use the color, and most of my students will follow along on their black and white, but even though they can do this exactly on their black and white. So the emulator is just now, and you can upgrade to it to be able to bring those states in. So that was the maze question, and it kind of highlights that also that way to get questioning going with the ask being dependent. There's another fun little activity that is on the second page of this, which I'm going to load. And this one now takes and compares two populations growing, but I've got to have ask being the independent. And I'd like to share with you that activity is now given on the next page where they have two populations. Here it's a little clearer. The guppies are growing at one rate and the frogs are growing at another. And they now look at the verbal to try to come up with the equation and explore when will there be an intersection point. So let's explore that. And I will build the formulas with them. And one of the things that I've noticed sometimes is if I have a screen, the view cubed over here, and it blocks this out, all I do is just move my cursor down there and then refresh it. And so I have my equations. And what I'd like to do is go to my table. And if I just start entering, again, it's kind of Easter egg hunting. How are they changing? And I can go in any order I want to, and to see, well, I kind of identify frogs and guppies, but when do they overtake each other? Now, what helps make things stick is there's some kind of processing time. So when I have done something that was step by step, now the students, if you were in auto, all of this would display right in front of them, kind of like sticking the fire hose in their mouth and saying, drink. You know, and here I can actually delete and insert, and I can walk one step at a time to get to see when is red bigger than blue, and here it happened. And now if I want a more refined number to one decimal place, we can even not have to worry with delta table. And so, by the way, this was rigged to be nice. But you can kind of get that. What we've done is spaced out the difference in how they're getting the content a little bit so that it sticks better. Not that the students are spaced out, but the content is spaced out, and that really helps, you know, making them feeling that they're in more control of it.
And John, I like that you said that you have to have a moment for the students to pause and reflect. You can't just rush through it. They have to ask, what do you think is going to happen next as you're moving down the table, et cetera?
It really isn't possible, you know, when you have all of this thrown at you. And honestly, that kind of brings us to another activity that I had learned factoring the way, you know, by drinking by fire hose, where everything was chilled to me in 2 weeks. And one of the things that's hard for factoring issues is kind of relating it to real life. And if you notice this screen, here's a person who wants, his name is Herbert, he wants to lay blocks down on his patio. And this, one of the ways the students could look at this real world, and it does tie to factoring, is how many square 1 foot by 1 foot blocks would he have for this area, and they can count the area and 3 times 4, and what's his flower border, and that's a linear, so you'd add 3 plus 4, which is 7. So we have 2 things, a 3 times a 4 and a 3 plus a 4. And so this activity, they can actually draw the flower bed borders, given that there's one that's 18 square feet, but it has the 9 feet of flower beds. And so they're hands-on right here, not using the calculator to do this, but just understanding these number pairs, connecting it, and they may notice that there may be more than one answer, and then you just hand out ask for the dimensions. What's cool is that this then can be kind of gotten into a practice. So when you go here, to this, here's another kind of action consequence activity. I've got this program called number pairs. You'll get this program also in your documents. And to put the program on your calculator, you would click over here on this magnifying glass to where it's like lifting the hood of the calculator, where you see the engine and add the oil, and you then throw the program under the hood. And then you go back to your emulator. That's an easy way to do it, and we have another handout for how to link it to one student's calculator to another. If you're trying to link something to a calculator, have one student walk in and say, I have Tetris, who wants it? And the students will just teach you, and it'll work. So I just would like to show you this program. It asks for a sample question, and there's some directions again with this. I'm going to hit yes, and it's asking you to press enter to see that 9 and 9 are there in the handout there. And 99 is meaning that you would time things. And now I ask for the pairs, and if I'm going to quit, because there was something I also wanted to show you when you go in, that I can refine that every product and sum is positive. Every product is positive. Every sum is 0. So I can refine this little program so they're only practicing on certain examples. Now, I might think that it's 6 and 5 because 6 and 5 add up to 11, but really, it'll tell me what to do wrong, and I can even see, well, maybe you should sit with this program and try to get 10 right in a row in less than 5 minutes, or whatever your timing factor is. And you can then help them practice these number pairs, which I'm going to quit out of this. And another way to quit out of a program, if you ever want to just abort, is press the on, and it'll get out of it. But what's neat about it is back to those questions. So when I go into questions and I ask what is the thinking behind it, if they've played with the program, now what's really going to make things stick is if they ask to elaborate their thinking. How do you know what to enter in that program when you have the product of two things that are positive? And then I might have some in groups where kids in groups are talking about, well, when their product is always positive, what's kind of the strategy, or when everything's 0. Now, there's ways to get this on the internet as well, and they're called diamond problems. You may have seen them, and there's some links that you'll see. And isn't that marvelous? Yeah, I love to get them to talk to you. But these diamond problems, if you don't want to use the program, here's a handout you can just adopt. I've got it in Word and in PDF, where this is a much easier level, where now they have to add the two numbers to get the bottom in the diamond and multiply the two numbers to get the product. And so you can see where you're going with these. You have to kind of break down where the skill level is. And here's a little harder. And then finally, this is where the number pairs are. So these can be adapted, and they might notice when 0 is the sum, these are opposite pairs. So that's kind of fun things there. If you have an old Smart View, we have a button, or we have a document on how to upgrade your Smart View for free. No cost at all. What ties into this is then factoring and zeros, and there's more there to be had, which, of course, we only have an hour. But I wanted to share with you that when you go to the documents, you'll get some factoring fun where you can actually press and get zeros, and use a graph table mode where you can actually compare zeros to factors. So that actually is a nice approach to get there. Just to kind of share with you that I think we have the action here that you can get the thing in the calculator, I'll load it there. I have loaded in my calculator a a product of binomials and I want to ask about the zeros, one of the things that's kind of nice is to mix the graph and the table. So we could get to a graph and table, and this then enables me to walk the table. Now, left arrow gets me to the other side of the table. Down arrow says, here's how to get to the 0. And you can do this right on the old black and white and to get to the other 0. So I can kind of get the understanding between zeros and factors. There's a lot more to that, but that's for you to enjoy outside of the webinar, because I do want to notice that we have a drawing to give. So there's some more to that. And are there any questions, Karen, that need to be addressed that we have a chance to finish up with?
Somebody just asked about the connection between zeros and factors, and I suggest that you take a look at the format in the transformation graphing that has a quadratic in factored form. That's a really lovely connection.
Yes, and I do agree the vocabulary is an issue because zeros they don't know what a 0 is, and this in fact might be how to get to the zeros. I'm going to scroll to that part where they have zeros here listed based on the graph and that the output is 0. As far as how to get to download our activities, we're going to have Mike tell you that. So yeah, I'm going to pass that to Mike now.
And while you're passing it to Mike, I just want to say, folks, there's some more stuff in the handouts. There's lots more that John and I wanted to share with you that we didn't have time, but you'll notice we did real contexts, we did multiple representations, we explored dynamic activities in a way that gives students an opportunity to reflect on what they are looking at and what they've learned. Mike?
Thanks so much, Karen and John. A couple things as we wrap up tonight. First, if you visit our website and look under the Professional Development tab, and slide down to webinars and tutorials. On the right-hand side, there's some technology tutorials, and earlier some people were asking about how to load apps onto the handheld. And go under graphing, that first choice. And then, again, first choice, the TI-83 plus, TI-84 plus graphing calculator families. And tonight I happen to just double-check under the second atomic learning link. And I slid down to L, using TI Connect, and videos 4 and 5, downloading, installing apps and programs, part 1 and part 2. And it's nice because they're nice and short. They're also free, so you can watch them as many times as you need to in order to make sure that you're getting the help that you need.
Mike, that's awesome. And can I just throw in, too, that on the SmartView emulator itself, there's a help menu that'll take you right to either a PDF or online, and that may help you with the SmartView as well as the CE.
Thanks so much, John, for reminding me of that. I forgot. Earlier, we did mention that we're going to be giving away to one lucky winner a conference registration for the T-Cubed International Conference, and tonight's lucky winner is James Zuber. So James, we hope to see you at the T-Cubed International Conference coming up in early March in San Antonio, along with everyone else. It's really a great place. Like I think John and Karen both mentioned that they had a lot of material planned for tonight, and we only had an hour. So imagine if this was a conference session with John and Karen and they were in front of you, and all of a sudden that 60 minutes is up and people are walking out. The nice thing is you still have John and Karen that you can talk to as they're walking down the hallway and really get to know them a little bit better and pick their brain about some of the other stuff they had planned for tonight. So that's one of my favorite parts about the conference, is just having time to learn and digest and make connections with other educators. It's really great. To receive a certificate of attendance, click the link in the chat window. Also listed is a link for the documents, which I know many of you are really excited about. Karen and John really did an extra fabulous job tonight of putting together documents that are really, really amazing. We haven't we haven't had two people spend so much time on documents as much as they did in a long time. So please use it and appreciate it. They did spend a lot of time. If you happen to miss the certificate or the documents link, or they're not working for you for any reason tonight, stay tuned. You'll automatically get a follow-up email in a couple days. In that follow-up email will be a link to the recording, a link to the documents, as well as a link to the certificate. And if you happen to be watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. Last but not least, before we thank Karen and John, we have a unique opportunity tonight. With us online is Margot Menkes, and Margot actually works for Texas Instruments. She is one of the people that develop the TI-Nspire Plus family. So not only is she great to help answer questions, but she's also one of the people that helps program the functionality of that calculator. And we're always looking for people to give us feedback, and I know Margot reached out to me tonight, and she's actually looking to see if there's anyone that would be interested in receiving some pre-production software of the SmartView software to be able to provide feedback to Texas Instruments, which is a really unique opportunity. So Margot, if you don't mind posting your email in the chat window. If you're interested in becoming part of our TI customer feedback team, please feel free to contact Margot and reach out to her. Thanks so much, John and Karen, for everything you shared tonight. This hour really seemed to fly by, especially fast tonight. And I don't think it was because you were going fast. I just think that there was so much to take in, and it was very engaging. So thanks so much.
You're most welcome.
I'm so glad that we were all together tonight. Thanks again.
And thanks again, everyone. I just saw that Margot did post her email address in the chat window, so please feel free to email her and reach out. And we'll hope to see everyone back online real soon. Have a great night.